Alright, looking at 5.6 HL congruence. This homework here, the first questions ask if the triangles are congruent. If so, identify the congruence theorem and prove it. So for this first one here, we're looking at triangle ABC and triangle BAD. Okay, what you'll notice is they both have a right angle, so they're both right triangles. You will also notice that they share a congruent leg, and then lastly you'll notice that they have shared hypotenuse. So if you pull this out, oh, that didn't work. That should work. There we go. You'll notice that both of these are congruent by HL congruence. Okay. Two right triangles that have a congruent leg and a congruent hypotenuse are congruent triangles. This one here, you'll notice that this HF is congruent to HF. That's reflexive property. You'll notice that they both have this right angle, and then they both share this congruent angle. So we have angle, side, angle. Looking at this one, you will notice that they share in the middle SQ. You'll also notice that they both have a right angle, so they're two right triangles that have a congruent leg. SQ is congruent to SQ, and then you'll also notice right here and here, those are the hypotenuse of both of those. So those are congruent as well. As you can see right here, just like that. HL congruence. Okay, this says AE and BD are altitudes. Right when you read that, I would just automatically, we know the conclusion of the statement that the line segment is an altitude, that it creates a right angle. So two right angles in this case. And then the same thing is going on for BD. So this is a right angle, this is a right angle. It says CAB is 80 degrees. Oh, before I do that, AE is also a median. That's important as well. So since AE is a median, we know that CE is congruent to EB. Okay, I'll put in CAB is 80 degrees. CBA is 60 degrees. They say CE is x squared minus 56. And then they say BE is x. So I'm going to start out with the fact that we have these two segments, which we know are congruent since AE is a median, so we can set them equal to each other. We know that they are equal. What you'll notice is we have an x squared value, we have an x value, and then we have a constant. So this is a quadratic. So to set up a quadratic, you need it to be in the form of ax squared plus bx plus c equals 0. So to do that, I need to, let me get this out of the way actually. I need to subtract x from both sides. I get x squared minus 1x minus 56. X minus x is 0. So now it's of this form, and you can either use the quadratic formula or you can factor. And we've done this many times in class. We did this last year as well in algebra, and you will continue to do this. I know that the two numbers that go here and here must multiply together to get negative 56. So that's why I put a plus here and a minus here. And then, if you look, let's change this color. The b value is -1, so that's the sum. So these two numbers here and here must add up to make -1. So what are two numbers that multiply together to get -56 that when you add them, you get -1? If you work this out, I think a fun way to, or an easy way to do this is have your product and your sum, -56 and -1. 8 and 7 works, but if you did 8 and -7, you get 8 minus 7 equals +1, so that doesn't work. So then you try -8 and +7, and you'll notice that these add up to -1. So we have +7 and -8. So now it's factored. And really at the end of the day, I just want to know what can I plug in for x so that this equation is true. And to do that, you just need to make sure that whatever you plug in for x, first in this parentheses, if that equals 0, 0 times anything else is 0, so that would work. So what can I plug in for x here so that this equation is true? 8 minus 8 is 0, and that's going to give us what we need. And if you plug in here, if you did -7, -7 plus +7 is 0, 0 times anything is 0, and that works. So x equals -7. But you need to think, if you plug in -7 for EB, since EB is just x, we don't have negative line segments. So this one's not going to work, you could cross it out. Alright, let's look at these angle measures. Okay, so what I notice is AEB, this triangle here, maybe I should zoom in. This triangle here has a 90-degree angle, and it has a 60-degree angle. So you got to think, this angle plus this angle plus this angle equal 180. So 90 plus 60 is 150, so this angle here must be 30. If this is 30 and the whole angle here is 80, we know that this angle, let's use a different color, here must be 50. Okay, if this one's 50 and you're looking at, let's get a different color, you're looking at the triangle AEC, you notice 90 degrees here, 50 degrees here, so this one must be 40. So they all add up to 180. And I think that's sufficient. It's asking for the measure of angle C. We got is 40 degrees. Measure of angle AFB. We need this angle now. That's the one we're missing. Grab a different color. AFB is this angle. You'll notice we have a triangle here. And let's see. Okay, it looks like I'm going to have to first, this is a fun question. Looks like I'm going to have to first, let me get a different color. Look at this triangle. This right triangle here. We have 40 degrees here, 90 degrees here. So this angle over here must be 50. Get this out of the way. Let's use this purple color. It's blue. This is 50 right there. So if we know that's 50, this one down here should be 10, so that they add up to 60. Now I can find this remaining angle, AFB. AFB, if we have 30 and 10, we know the remainder must be measure of angle AFB should be 140. And then the length of BC, we got to plug in that value that we got for x. X equals 8, so if I plug in 8, I get 8, and I don't need to plug in 8 here. I know because if this is 8 here, then this is also 8 here. So the length of BC must be 16. Okay. Alright, this one's a little bit easier. It says, given that the measure of angle P is, and maybe I can make this a little cleaner than the last one. Let's clean this up. So this angle here is 10 degrees. RM is an altitude, and they already drew the right angle there. But that would be the conclusion we make from that there's a right angle, RMO. And it says RO bisects angle MRP. So let's look at angle MRP. If RO bisects it, it cuts it into two equal angles. Okay, so we have that bit of information. Now, if you're just looking at this triangle, the whole triangle, you'll notice that we got a 90-degree angle at angle M, a 10-degree angle at angle P, and then the whole of angle R must be supplementary to those two angles. So 90 plus 10 plus the angle, measure of angle R must equal 180. So what I'll do is add up 90 and 10, I get 100, so the remaining angle must be 180 minus 100 equals 80. I'm sure a lot of you just did that in your head. So this whole angle is 80, but we know that that angle is being bisected by RO, so that we know these two angles are 40 and 40. Because they have to be the same and they have to add up to 180. So ORP and the measure of angle MOR. Okay, so we have ORP. ORP is 40, but now they also are pointing to this angle here. This angle here, and if you're looking at that triangle, you should be able to tell that this is 50. Because all those angles inside the triangle have to add up to 180. Okay, I don't have enough time to do this problem.